Assalamu alaikum. My name is Usama and these are my co-partners Hamza Sami, Ehsan, Mubashir Islam and Aksa Khalid. Today we are presenting paper which is phase reconstruction from voice using generative adversarial network. In this paper we address the challenge posed by a sub-task of voice profiling, reconstructing someone's face from their voice. Before going on in details, I will give you some basic idea behind generative models and GAN. Generative models are those which use unsupervised learning approach. It has some random input variable X. We train this input variable to see pattern in data to generate output. Basically, you can say that you take a lot of training examples from training set and generate those training examples. Some of them gives you estimation that gives probability distribution. Some gives you new samples that come from the same distribution just generate training set. Some examples of generative models are variation, autoencoder, Markov model, Gaussian mixture model, gang, vanilla gang, deep convolutional gang, and conditional gang. These are the types of gang. Our paper proposed method is based on vanilla gang. Gang is a deep learning based generative model. In this model, we two neural network compete with each other to create or generate variation in data. Gang is consists of two submodels: generative model, which inputs and generate fake data; discriminative model takes generated and real data and discriminate between fake and real data. So how we can train GAN? This happens in two phases. In first phase we train discriminator and freeze generator. In second phase we train generator and freeze discriminator. In layman's terms, if I divide the training in steps, then in first step I define problem and collect data and choose architecture of GAN according to my problem. Then I train discriminator on real data. After that I generate fake inputs from generator. Then we train discriminator on this fake data. That's how the loop runs. Now I will invite Ahsan to explain further.
Related projects reported in our paper are voice profiling, face generation using GAN, voice to face matching, etc. The main contribution of this work is introduction to a new task of generating faces from voices and the proposal of simple but effective framework to perform this task. The proposed framework consists of generator, voice embedding network, a discriminator, and a classifier. The recorded voice is converted to a spectrograph using short-time Fourier transform, and it is used to feed the voice embedding network. And the voice embedding network used in this model is a pre-trained model from speaker recognition task. During training phase, only generator, discriminator, and classifier are trained. On the training model, two requirements were imposed. First, it should generate a realistic face. Second, generated face should match with the face of person whose voice was fed to this network. In this framework, discriminator classifies generated image whether it is a real or fake image by binary classification classifier. And the classifier infers that the identity of generated image and the identity of voice belongs to same class or not. In the training phase, the classifier and discriminator are not needed, so we remove the discriminator and classifier from model.
CNN are used as neural networks in our models, and loss function which we use is cross entropy loss function. Now coming towards the flow graph, voice embedding network take voice as input and output the voice embedding vector. The generator takes that vector and generates a face from this vector. This face is fed to the discriminator model and classifier model. Discriminator check either its realistic face or a fake face and computes its loss, while classifier assign the face to a specific speaker label. This loop continue until the generator start making realistic faces and learn the realistic data. FT and FC try to minimize their losses, while FG, the generator, try to maximize their losses so it can learn the pattern of the data. In our algorithm pipeline, first we take n voice samples and m face samples from our voice and face data. After that, Discriminator compute the loss and update its parameter theta d by ascending gradient descent. Then classifier update its parameter theta c in the same manner. In the last, generator checks the outputs of discriminator and classifier model and learns its parameter theta g. This loop continues until generator start making realistic faces and learn the pattern of data. Now Aksar Mubashir will explain the experimental and our results.
Data used consists of intersection of following two datasets having identity labels. Voice recordings are from Voxelab dataset and face images are from VGG face dataset. For voice recordings, voice activity detector from WebRTC project is used to classify a piece of audio data as being voiced or unvoiced. Audio clips are cropped randomly for training, but entire recordings are used for testing. Images are cropped by similarity transformation, which means that cropped image is similar to the original figure. Each pixel is normalized by subtracting and dividing by same value, that is 127.5. For training, they used Adam optimizer with following parameter values. Betas are the coefficients used for computing running averages of gradient and its square. In the table, we can see details of 4 CNN architectures. For voice embedding network, 1D convolutional layer is used, followed by the batch normalization and ReLU as activation function. For generator, 2D deconvolution and stride is used for upsampling with ReLU as activation function. For discriminator and classifier, 2D convolutional layer with leaky ReLU is preferred because leaky ReLU allows negative values as well. Note that fully connected layers are not used in discriminator. Instead, convolutional layers are flattened and passed directly to output layer. As a first experiment, they gave 4 different types of noise signals as input. For example, first row in figure represents synthesized images obtained from white Gaussian noise at different time durations. We can see that images are blurry, unrecognizable, and generally alike, but results do not improve with longer noise recordings. Here, regular speech recordings are given as input. In the figure, a row represents generated faces on left and corresponding reference images on the right. We can see that outputs tend to be more realistic and generator has learned to produce face-like images in response to actual voices. We can subjectively evaluate the actual output of network. Results indicate that longer voice segments results in convergence and synthesized faces are age and gender matched with speaker. Here, 7 different speech segments from entire recording are used as input. Generated and reference images are shown in figure 3. Images in each row exhibit reasonable variations of same person except fourth image in first row. This exception indicates that model is able to build a mapping between speech group to face group, thus retaining identity of face across speech segments from same speaker. Now Mubashir will explain about experiment on given code.
We produces our own result from the given GitHub code. We start producing the result by using the pre-trained model which were trained on the given data set of different people voices and their faces. Then we use the given example data to generate some faces, and in the end we use our own voices as input and generate some images, as well as we also use some noises and generate their face image also. Results from the example data is
I was a handful, I guess.
My local people here, I feel so excited and feel so proud of
Rachel Griffin, and so much more. You know, I was very surprised by the talent of the writers.
results from our own voices of group member Hamza Sami.
Hello, my name is Hamza Samin. I'm student of Masters of Electrical and Engineering at Information Technology University.
Aksa Khalid.
And I'm gonna put it in a bowl right here. And this is like rice powder.
Mubashir Islam, testing voice to face cameras. And in the end we use some noises like room cooler noise and also we use silence. and also water. Thank you.